Right. So, hello everyone. My name is Kaan, and today I'll be talking about Verifier Alliance and also a bit of Sourcify. So first, the Sourcify project. Sourcify project is a decentralized and open source smart contract verification service in really short terms. We started as a Solidity side project around 3 years ago, then spun out into its own project inside EF. So right now we are an EF project, we are EF funded and yeah, we're consisting of 3 people, like it's me, Kaan, Manuel, and Marco. And if you have heard about Sourcify before and even watched one of the talks, you would hear me talking about many other things such as the Solidity metadata JSON, human-friendly contract interactions, NatSpec, IPFS, and all of the stuff. But these days, recently, we tried to narrow our focus into one thing and the only thing, and it's being decentralized and open source smart contract verification service. And especially the emphasis on decentralized and open source, because this implies that currently it's not decentralized and it's not open source. The smart contract verification in Ethereum. And this is also because right now everything relies on our dear friend Etherscan. And as you all know, if you want to verify a contract, you just by default go to Etherscan. Not that Etherscan isn't bringing a lot of value to the ecosystem, but as we all know, they are a private company, they own all the data, you need to use their API, pay for their API. And I would say this does not really align with the ethos of Ethereum and all the blockchain space. And what we want to do is to change this, at least to push people in another direction. But before that, let's have a recap what smart contract verification is, what actually we're trying to do, and why it even exists. So the very reason smart contract verification exists is because, again, it's a slide from Etherscan, but here what I want to emphasize is this part, that a contract on blockchain lives as a bytecode. It's when you upload a contract, when you deploy a contract, it's ones and zeros. And if we want to see what this contract, what this program does, we need to read the code as in a human language, in a natural language. This can be Solidity, this can be Viper, Fe, Huff, these are new languages. So it's written in a human readable language, in a natural language, but then it compiles down to the language that machines can understand, which is bytecode. And this is how a contract lives on chain. But as I said, we write code in human language, in Solidity, in Viper. And if I come to you and say, okay, this is the code of my contract, there you go. Do you want to interact with this contract? And if you were to say yes, and click sign and send the funds to this contract, oh, how do you know this contract actually does this? What if I show you this code, and actually behind the scenes, the real code steals your money? Right? At the end of the day, when interacting in Web3, you're always interacting with a financial application, and at the end of the day, you need to know what that contract really does. So, how do you know that my claim that this contract is this one is true? And this is where the verification comes to play. And this is the familiar UI that we all have if you've been in space, if you use Etherscan, the de facto standard. And it's the green tick over there that everyone wants to see. Like if you see the green tick, you're happy. You say, okay, great. This contract is verified, and I'm happy. And this, what it allows is, if the contract is verified, now you can read the contract. Like you can see what the program actually does. If you are not a technical person, then the community or the auditors can do that for you. So I would say the verification is the very basis of everything else on top of it, on top of what Web3 is built for, like open source, transparency, permissionless, trustlessness. These are all possible because of the smart contract verification. Yeah, we see this, we're happy. And how does it work? Of course, in general, this is more complicated than that, but I'll try to explain the basics here. So let's say you have a contract, and you've written your code in Solidity, in my contract Sol, ownable Sol, ERC20 Sol. You have these source code, and you compile this contract with certain compilation settings. Like you will have a version, optimizer, if you want to use optimizer, how many runs you have, etc. There's a long list of compilation settings. So we take these source files and the compilation settings, how we verify the contract, and we give it to Solidity, to a Solidity compiler. So you want to verify a contract, you have these files, you give a verifier these, and at the end of the day we have a bytecode for this contract. Next, what we do is we want to associate this contract with a contract on chain. So we have a contract in any chain, in an EVM chain at this address, let's say. Then we call the ETH getCode RPC method to get the bytecode of this contract. This gives us another bytecode. And if these bytecodes match, we say, okay, all these files are the source code of this contract. So at the end of the day, it's verified, and now you are able to read this contract. And how does Sourcify solve these problems, well, especially the decentralization and the open source aspect of verification? Well, we are open source. Sourcify is a fully open source project. This is our monorepo where our main building blocks live. We also have another external repo, but at the end of the day, anyone can run their own Sourcify. Anyone can see how the verification works, try to replicate the verification, etc. And at the end, that's actually what people do, and what we want people to do is run their own Sourcify. One example is Hashscan. Hashscan is the main, let's say, one of the most popular block explorers in Hedera chain, if you heard about the Hedera chain. And they are using behind the scenes their own Sourcify fork. Thanks, like this way they don't need to build a verifier from the ground up. We are decentralized in the way that we share all the files on IPFS, all the contracts. There are more details into how contracts are stored and how they are retrievable. But yeah, our contracts are on IPFS, so anyone can download the whole repo. These days we are moving into a more database-based repository, but that's also going to be publicly available. So you don't need API keys. You are going to be able to download all the data we have. So our data is completely open. Currently, Sourcify supports around 152 chains. These range from the main chains such as Ethereum, L2s, Optimism, Arbitrum, to every little chain that you can think of. As long as you have a RPC and you have added your chain to chain list, there's the Ethereum list.chain. As long as you have added your chain there, you can just start verifying contracts on Sourcify. And how we verify contracts is either through the Sourcify UI, our website, and use the API. And we also have an import from Etherscan feature. So if you have a contract verified on Etherscan, you can, with one click, already import that contract and we verify it ourselves as well. We also have tooling support. So Sourcify is supported in Hardhat. Currently you just need to go and enable Sourcify explicitly. We are hoping to change that, so we we hope that the hardware support will be enabled by default. And you can, if you also have a different sourcify server, you can give a different sourcify server, like a local one, or if there's another instance. And after that, you can just, as usual, say hard.verify your network and the contract address, and this will verify on Sourcify, and if you have provided an API key on Etherscan as well. Similarly, for Foundry, you can also verify your contracts on Foundry for Sourcify. The only thing you need to say is to say that the verifier is Sourcify. Again, if you have a custom URL, custom Sourcify, you can give it, or by default, it will default to Sourcify dev. And yeah, the chain ID and the contract address you want to verify. We also have a remix plugin where you can verify your contract. If you have compiled your contracts on Remix, you can verify those contracts using our plugin, again by selecting the chain and the contract address. But we are working on a new Remix plugin these days, a new Verifier plugin that will combine all the verifiers into one single plugin, because we believe contract verification should be, let's say, decentralized in the sense that you don't want to verify in one place only. Right now it's Etherscan, but we believe the verification should be everywhere. Like if you deploy a contract, why not verify it on Etherscan, on Sourcify, on BlockScout, on every single verifier, so that it's basically verified everywhere. I don't see the point. Yeah, I think the parallel verification should be the default in the ecosystem. And we're working on a plugin that will do this behind the scenes for the user. So the user wouldn't even have to notice they are verifying in all these places, they just want to get this contract verified. But this is not an easy task, because essentially what we are trying to do is to change the user behavior, and the current behavior is just defaulted to Etherscan. And to overcome this, we need to join forces with other players, and that's what we do and what we did. And we found an alliance called the Verifier Alliance with all these people, BlockScout, RouteScan, Dora, Tenderly, and with the help of Sam. We found this alliance to gather all the smart contract data out there in one single place in a standardized way, and yeah, easily accessible and open. So, what is Verifier Alliance? Vera, in short, Verifier Alliance is an ecosystem collective of aiming for easy, unified, and open access to the source code of EVM smart contracts. Because currently, it's not easy, it's not unified at all, and it's not open access. It's difficult to get all the contracts. And yeah, at the end of the day, it's simple. What we do is we just take all the contracts and put it down in one place. That's simple. At least at this stage, it's just the main goal to have everything in one place, in one database. And from there on, we will see what else we can do together. How it works is the alliance itself is not a platform, so you don't go to alliance to verify your contracts. You just go to one of these verifiers or data providers. You can verify your contract in BlockScout or in Sourcify or, I don't know, in Tenderly. And these verifiers will push the contract to the shared database in the shared format. We have a certain database schema, and it is outlined in this URL in Verifier Alliance/database specs. And from the overview, it looks like this. It's a PostgreSQL database currently, and we have different tables for different parts of the contract. So we have a verification table, and a verification is essentially a match between a deployment and a compilation. So let's say you have a chain that is deployed, you have a contract that is deployed, and you have to You have a contract that is deployed and you have the source code and you want to match them. That's the verification part. We also separate the code and the contracts so that if, for example, the same contract is deployed, then we can deduplicate it. I will be giving more details about this. So this is, in general, how it looks. As I said, we decouple the compilation from deployment so that we can reuse everything. And you can both verify the contracts in runtime or creation code. So we have separate fields for if you verify this contract with the runtime code or the creation code. And one of the neat things we do is we normalize the bytecode when we are verifying, and we add transformations on top of that, what we call transformations. And transformations are the transformations that we add on top of the bytecode. So when you have libraries, if you have immutable variables, if you have the metadata hash, these parts are either replaced or appended to the bytecode. That's also another example is the constructor arguments. These are the changes that you do before deploying your contract, and we just strip away the code from these changes, save the normalized base bytecode, and on top of that we add the transformations. Let's look at some examples for these. So here, for example, this is a transformation on top of the creation bytecode, because we have a constructor argument inserted at the end of the contract, and a replacement of the aux data. Aux data is the metadata hash part, if you are familiar with that. So in this contract, there is one replacement of the aux data and an insertion of constructor, and the values are stored below in the next JSON. Another example is from a runtime bytecode here. Here, for example, there's a replacement of a library address, replacement of aux data, and a replacement of immutables, and the values are there. And for example, I put this example for this case of the transformations. Let's say you compiled the contract, and the compilation output of the runtime bytecode is this. So you have a library placeholder, a placeholder for immutables, and you have the CBOR aux data at the end of the bytecode. So this is the compilation output. Then you want to match this compilation output to this on-chain contract, this deployed runtime bytecode. And you can see the differences. For example, here, the library address, when the contract is deployed, the library address is filled with this value. Then the immutable placeholder is filled with this value of the immutable, and then, but the CBOR aux data remains the same. The metadata hash does not change. And how we transform this, how we do transformation, is we just put zeros for all these fields, and if you have another contract, for example, that has the same contract, the very same contract that is deployed with a different immutable or a different library address, then we can use this base normalized contract to verify it again. So you don't need to have another bytecode row in the database. You can just use the same code, add different transformations, and you have the same contract verified. So last time I checked, there were around 800,000 and 900,000 verified contracts from all the data providers, and it's growing. There are still, some of the providers still have not added their historical data, so now it's flowing, the data is flowing real time, but it's not all of it. Like, so this number will go up substantially. And it's, at the end of the day, it's not only a database. The database is the very first output of of this alliance, but it's also a knowledge base for contract verification, because not only the code is closed source, the knowledge is also closed source. So all the knowledge, let's say, discovered through contract verification in Etherscan stays inside Etherscan. And also we want to create test cases and create a base knowledge for everything we have learned so far from the contract verification. And in the future, using this standard, there can be tooling built, because we also, at the end of the day, will have a schema and a standard way to save verified contracts. For example, one can build a tool to easily pull the data from here and just verify locally on your browser. And on top of that, other features can be built. For example, bytecode similarity search, meaning you see a contract on a block explorer, but you don't have the source code for this contract. What you can do is you can approximate this bytecode and say, okay, like this contract is not verified, but this actually can be this contract, maybe contract B, contract C. It's 90% contract A, but maybe 60% contract C. So we can have similarity search to unverified contracts. And right now, we just yesterday started sharing the data publicly, completely in Parquet format dumps. That means the whole database is available to download and will be accessible by the public easily. And maybe in the future we will have, we are thinking about maybe having some API access for this data. But this is not the very first use case that we want to do, because maintaining an API, a public API, is not easy. And yeah, the first use is just opening everything up and see what interesting things can people come up with. So yeah, at the end of the day, this is what Verifier Alliance is about. We have a website at verifieralliance.org. Our GitHub contains the schemas, some specifications. You can follow us on Twitter. We have also a public Telegram chat if you want to follow along and if you have any questions. And also, this is Sourcify's website and contact details. So if you're curious, you can give us a follow. That would be it. Thank you.